This is a clip or laser Doppler interferometer, and what we're doing right now, we've just done a scan of a 6.5-inch aluminum cone bass driver for the AirPulse Model 2 loudspeaker. This is a frequency of 515.6 hertz, and this is a 3D animation of the cone. We can look at the cross-sectional view that way to see this is like the dust cap, the surround, and the cone in the cross-section. That's the 3D of the cone, and you can see it's working like it's almost like a piston. You can go back to here, and you can see the speaker moving up and down, and it's staying fairly linear up to that point. But when you get up to frequencies up, let's say around here, which is 2,343.8 hertz, you can see this is a very increased parameter on the cone. Doesn't actually look like this when it's running at these frequencies. We exacerbate the magnitude a tremendous amount, so we can look in great detail how the cone is actually behaving. And if you go to the cross-sectional view, that's exactly how a speaker cone behaves. And you can see that the voice code's moving up and down at 2,343 hertz. The cone has got virtually no representation of what the coil is doing, yet it still sounds musical. And that's what you hear. That's why all speakers sound different. It's how the cone behavior is in relation to the motion of the coil that makes the difference, and the radiation banding, the radiation analysis here. And we can shift it down here to around here, and you see how it'll widen out here. See, it's like almost like 180-degree dispersion, and that's when you get up to somewhere like here, when you look at the radiation analysis, it's like a polar response through the dispersion of the speaker. You can see that's 8,000. That's way above the crossover frequency of the driver. So that gives you an idea. See how you can see how the dust cap is actually oscillating in and out this way. How it's actually in severe breakup mode, like oil canning. But that gives you an idea of how the speaker behaves at different frequencies. In order to get accurate measurement, we have to use a highly stable platform. So what we're doing here, we're using 6 inches of machined granite that makes sure that this table is absolutely it's isolated from any mechanical vibration the floor may have as you're walking across it. And this is the device that we use for measuring the analysis of loudspeaker suspension systems. This is known as a voice coil spider or damper, and it's excited on the other side by a massive 18-inch metal cone subwoofer. This is how we do dynamic analysis of loudspeaker suspensions. When you do it statically, you don't really get the true performance of the speaker, so we do everything with dynamic measurement. And these things here, they're not like kids' play toys or anything. These are like actually machined weight that we add to the suspension of the cone, so we can calculate the mass of the cone and how that works on the suspension system.